In the warm, nutrient-rich city called host, bacteria lived fast and divided faster. For decades, the humans above believed they were in control. Every time host fell ill, they unleashed their chemical weapons, antibiotics, confident that the invaders would fall. At first, they did. Penicillin swept through the bacterial neighborhoods like a wildfire. Cell walls collapsed. Ribosomes fell silent. Entire lineages vanished in a single generation. The survivors whispered a single rule into their DNA: adapt or disappear. Deep inside one bacterium, small, ordinary, nearly invisible, a mistake happened. A single point mutation altered the protein on its surface. When the antibiotic came again, it knocked and couldn't get in. That bacterium lived. Its siblings died. When it divided, it passed the secret on. Elsewhere in host, another bacterium took a different path. It didn't wait for mutation. Instead, it borrowed. A plasmid drifted through the microbial crowd like a forbidden book, carrying instructions for beta-lactamase enzyme, a molecular pair of scissors that sliced antibiotics apart. One touch, one exchange, and suddenly resistance spread sideways, not just down generations. Bacteria didn't need to be related anymore. They just needed to meet. The humans escalated. Stronger drugs arrived, broader spectrum, higher doses. But the bacteria were already rewriting the rules. Some built efflux pumps, tiny molecular bouncers embedded in the membrane, grabbing antibiotics and throwing them back out before damage could be done. Others quietly altered their targets, ribosomes reshaped, enzymes tweaked, so the drugs still bound, but no longer worked. Every prescription, every incomplete course, every unnecessary dose tightened the spring. Hospitals became training grounds. Farms became rehearsal halls. Wastewater became the great mixing bowl where resistance genes from humans, animals, and the environment met, recombined, and evolved. The bacteria were no longer just surviving antibiotics, they were anticipating them. The time bomb ticked softly. One day, a patient arrived with an infection that refused to respond. Then another. Then many. The lab reports used words once considered rare, now routine. MDR, XDR, pan-resistant. The last line drugs faltered. The cupboard was nearly bare. Under the microscope, the bacteria looked the same as ever-simple rods and spheres, minding their own business. But inside them lived decades of accumulated knowledge. Mutations selected by chance, genes traded in desperation, defenses refined by human pressure. They hadn't planned to build a time bomb. They had simply done what life always does when threatened. Adapt, share, survive. And now, as the ticking grows louder, the humans are beginning to realize antimicrobial resistance isn't a sudden explosion. That's a long fuse we lit ourselves, one dose at a time.